Hello, everyone. I'm Dave Rubenstein, editor-in-chief of SD Times. And today, the topic is Understanding Infrastructure Lifecycle Management and its role in scaling enterprise DevOps. I'll be discussing the issue today with Dave Williams, who, as he says, has been involved with DevOps since it was an egg. He's the vice president of strategy at Quali, but has also served as vice president of products and strategy at IBM Tivoli, senior vice president of product strategy at CA Technologies, senior vice president of strategy at Digital AI, and as an analyst at Gartner covering DevOps and IT operations. Before we start, I want to let you all know that this is going to be recorded for on-demand playback on sdtimes.com. And I also will encourage you to ask questions at any time during the presentation. Simply click on the questions tab in the control panel, write in your question, hit submit, and we'll get to as many at the end as time allows. So without any further ado, let me turn it over to you, Dave Williams. Go ahead, Dave.
Hey, thanks, Dave. And as those of you who can't realize, we're actually standardizing on naming as well. So it's something we had a decision on. Anyway, to start, I'd like to thank everybody for taking the time to join me today. I will endeavor to make sure that it proves both informative and useful for you. This topic is a very hot topic, obviously, because as a company, Quali is really, really embedded in the infrastructure automation space. So what we do as an organization is we see changes happening from a front seat. So as infrastructure continues to modify and get enhanced and augmented on an almost quarterly basis, infrastructure and the role it plays is becoming a significant increase in prioritization, which typically hasn't been true in the past. It's always been part of someone's role, but now infrastructure is really driving how people are working with the technology, and how it actually supports DevOps is really important. It's I always think of it as being the track that the trains run on. So the scaling of DevOps is a challenge. I will not spend a lot of time talking about just one perspective. So the one thing I really want to make sure is going into this is that the DevOps is a practice that affects a lot of people, from the senior organizations that look at it as a various way of deployment of technology into their business, to the developer who wants to make sure that the agile and the development practices are adhered to, and that speed of production and deployment are in case. So there's two types of people there that may or may not think of scale in the same way. So what I'm going to do is I'm going to slowly go through the way that we look at this, because infrastructure automation is changing the way that people are actually developing DevOps. It's moving DevOps, as it becomes more mature, into something that enables it to be a powerful business transaction weapon, as opposed to purely a development of product weapon. So the problem with infrastructure is today is it's assumed. That's the biggest thing. It's going to be there. No one is going to think that, oh, we'll plan the infrastructure, we'll have a whole team to build it, we'll do some special work on it. It's assumed. What that means is no one really thinks about it. It will be built, it will be managed, and it will be used. That's what it is. We have cloud providers that provide a whole bunch of components and capabilities. We have a whole set of technology and tooling that we can assume is going to be there, but the assumption is that infrastructure is going to be there. And that's more of a legacy challenge, because infrastructure has always been an underpinning part of IT, but infrastructure itself is becoming massively sophisticated in the way that it's hierarchical. And so therefore you need to understand what it is actually it's doing to support the product that you're developing. So there are a number of challenges, and you'll be relieved to know that I'm not going to go to every single one of these in detail, but these are obvious ones. For a start, the sophisticated stacks. So infrastructure, when people say IT infrastructure, it really depends on who you're talking to on what they believe that means. So to each individual personality that goes around a DevOps team, for example, someone that looks after quality control may be slightly different than someone that looks after the development of the actual coding. So even though they're in a small team and they work together, and that you've got the intrinsic testing that goes on, and you've got the scaling that you'll do, each person or each type of role will look at it slightly differently, or each type of capability, which is more specific. So as you do coding and you go into the testing and you look at security, compliance, etc., the way that you look at the infrastructure may change. So the stacks are becoming not only more complex, but they're also becoming more diverse. And there's different needs, so different people have different requirements. I mean, how do you explain what an operations person would look at the infrastructure as opposed to a planner? So you've got to look at it in a way that says, I've got a number of different types of people here who look at infrastructure differently, and how does the infrastructure support them and their role to do their job? It may be different. You can't treat it as a vanilla. So that's an area that obviously needs to be understood, that you need to understand who you're talking to on infrastructure. It can't be assumed that it's taken for granted. The other one is geographical. This one is multiple. You can look at this in multiple ways. One is the geographical spread of an application or a DevOps practice, which says you've got a certain amount of technology sitting in various clouds or on-premise or wherever you may have the architecture of the application you're building on, and the infrastructure takes that into consideration. But it also may be the end user. So the infrastructure, as you're looking at the continuous feedback, the operational aspects of how did what I just do impact the business and provide me with a good understanding about what improvements need to be made. The infrastructure at that point is more broad. It includes all the IoT, the end user devices, all the architectures that support the delivery of the application to the endpoint. So it can be changing as you go through, and the geographical spread can make the complexity that much more. So if you look at the stack, that could be built across one cloud provider, or it might be across multiple cloud providers. However, DevOps teams can choose what they want. So where I'm going with this is that you might have DevOps teams that have different geographical coverages, different cloud providers. So the spread is that much more hierarchical.
Yeah.
Then you've got the change frequency. So as changes come in, you're going to have them more frequently. And this is going to happen. I mean, change is going to be like normal. It's like breathing in and out. So change should be assumed that it's going to increase in in the way that it comes in. But how do you do that over a period of time? And of course, with more change requires more increased resources. You want to be able to manage it. And with more change comes frequency of risk, because you're doing more modifications to it. How do you do that within guardrails that says, I've got a piece of infrastructure here that I'm going to modify the configuration of? How do you make sure that that subtle change is not going to impact other parts or the application? And then probably one of the most important pieces is that demand, time, and effort and skills is there. When everybody does their job, well, no matter what it is, coding, managing the IT organization, doing the quality and testing, the infrastructure is becoming more and more of a role, more and more of a task within that function. So the more infrastructure management that is required, the less time there is to do the testing, to do the coding, and to manage the operations infrastructure. It becomes more of a burden and a greater impact in the environment generally. And then lastly, you've got the ability to manage the overall innovation. You can't stop innovation. Things are going to happen. Innovation is going to be restricted if you put standardization guardrails around. You can only use certain things. So innovation is going to drive the complexity of the stack. And so as new things come out, you want to be able to innovate very, as much as you possibly can, because your job is to differentiate and provide technology that can actually make the business more competitive. And I think that when you have innovation retarded by actually having the infrastructure stack, solidified into a static area of time, it inhibits the company to innovate well. And the development teams don't appreciate it if they're being restricted in what they do. So we should assume that innovation is going to continually drive not only the changes, but the technologies that come in and the sophistication of the stacks.
Mm-hmm. Dave, I just wanted to jump in there earlier. You talked about the different roles having different needs, and clearly that's going to present challenges for people when they're trying to manage the infrastructure. So I'm curious to know, though, what are the different expectations around infrastructure?
Okay, so let me see if I can go into this one. So this is the main crux. As someone who's been in the software industry a while, I would say that there's two things that you always have in your head. When technology applies itself to solve a problem, you're solving a generic. Typically, you're saying we'll do configuration management, or we'll do infrastructure, or we'll do something. The trouble is that you're typically talking to two types of people, and in DevOps is very tantamount. So when people talk about, I want to be able to provide you with standardization, which is what a lot of analysts will say. They say, which is a no-brainer if you think about it. If you standardize, if things are less complex, if things are really, a cookie cutter type of approach, then the ability to manage it becomes more effective. And that's always been the case ever since the days of Linux and distributed computing. You know, if you only have one flavor of something, then obviously the ability to manage it is that less. It ignores the reality that that's never going to happen. That standardization is a set of guardrails that you put around it, and you can try to manage it, but you're not going to restrict it. So standardization is going to be something that the business would want to hear, because they want to see fewer options. Fewer options means less risk, less costs. They want an enterprise view. So even though the DevOps teams will work pretty much, they can work in silos or they can work collaboratively, whatever it is, the enterprise wants to view all the practices, all the products that are being developed and what their stages are. So the enterprise wants to see that. And then that enables them to manage the costs. So if they understand everything at a holistic observability view, they can say, I know what's going on, I've got fewer options, I can see what the enterprise view is, I can manage the costs, therefore fewer skills, I can then gather change, I can then extract the detail. And the trouble is, abstracting the detail ignores the reality. And so the enterprise wants these things, and this is what they would like to actually have. And this is what it needs to be delivered to them. However, it shouldn't be at the cost of freedom of choice. People are still going to want to use what they need. Each DevOps team will use technology that supports the architecture of the application being developed. There's going to be more options. This is a world where things change on a very frequent basis. They want to get a product view. So even though the enterprise view is important to the business, a DevOps team wants to understand the product view. What's the end-to-end of that? All the way from planning, all the way through to when it goes into the business. So I want to understand that sort of view. I want my team to understand as much as they possibly can to ensure that what's being built actually provides what is being required. And there, so it's the product view. Other products, that might be useful to know, but it's not going to drive my day. They also want to be cost aware. What that means is that most budgets that are put into place, whether it's you're using open source or whether you're using cloud, there's going to have a cost of some description associated with it. The awareness of that cost enables decisions to be made more agile. You can actually do things, say, okay, that's within the remit. It doesn't mean you're held accountable directly to it, because that's the business. The business wants the overall view of costing and budgeting. It just wants to make sure that people, as they put things into the system, understand that everything comes at a cost, and that can be, you know, provided a much more digestible, less intrusive type of way. And then more skills. Everybody wants to be trained. This is not about hiring more people. This is about updating all the skills that are in the organization to make sure that they are ahead of the curve, making sure they look where the market is going and where the products can be developed more efficiently. So skills is a multi-dimensional thing. It's new people coming into the industry with different skill sets. It's new skills being required for the business, and it's the long tail of development. Most enterprises have a long tail, and what I mean by that is that there's going to be technology that's been around for a long time that still needs managing, caring, and developing as it moves to more the digital transformation technology. And then there's the bleeding edge technologies where there's much more DevOps practices, much more agile, much more lean practices going in, and those are in there as well. So it's a mixture of both those worlds. So you're going to have more skills with which to make sure that you're not neglecting parts of your infrastructure in support of only looking at the new pieces of infrastructure. And then they'll see constant change, which I've mentioned. And this is a detail-oriented world. I hate to say this, but when you talk about these things, the devil is in the detail. And so detail abstraction is good for the enterprise because it helps them understand what's going on, gives clarity of view, understands all those attributes I've listed. But when it comes to the actual work of building technology and putting it together in a way that the infrastructure supports it, then detail is critical. That's from versioning all the way through to understanding what the Git looks like and the artifacts and how they exist. That's something the business may not want to know, but it's something that's going to inhibit these more, I say, bigger view initiatives like standardization, etc.
Mm-hmm.
So, you know, this is so they, you know, when we talked about this is the utopian view. And again, I'm sure that everybody, you know, listening to this will say, yeah, that's sort of what we do. This is quite complex looking at it. You can say it's got common infrastructure foundation. This is where most people think about infrastructure. They think of the storage and the compute and the network. They think of the main components that sit underneath everything. But the infrastructure contains so much more. It contains the IDE, the development environment, the tools that are used. That's through the whole tool chain. the databases, the testing tools. I mean, the list goes on. And within each one of those boxes are all the options that you have. So each one of these boxes in itself is an amalgamation of many other sub component levels and the options that you have to choose it. And then you've got the right-hand side of that box, which is the operational infrastructure, which is basically, I've got the things that I need to actually manage it. So what are we doing to manage the infrastructure when it goes into production? How do I make sure that it's healthy? How do I make sure I can interact with it? How do I get the release from the development, if that's where it sits, into the operations group? And then, of course, you've got security, which is intrinsic through all of these practices, but can sit as a standalone entity if it needs to be. But you're really looking at it in different lenses. These are the applications. This is the stack that the infrastructure will look like from the end to end. It's unlikely that you'll have one infrastructure that looks like this. It's likely that you'll have infrastructure pieces that have, especially at the top level, the development foundational level, for example, or the operational level, they may be different in both cases, but the underlying pieces may have a lot of commonality between them. So this is what I call the X factor. So as a company, when we talk to clients in regards to infrastructure management, this is where, you know, you've really got to look at it in a way that says, how do I manage it, and how do I actually talk to someone of why this utopia doesn't exist? Yeah, because utopia doesn't exist for many reasons. One is choice through the stack, the preferences. I might want a tool in there. I mean, there's bias in every decision. You want to be able to have something that either meets your requirement or something you're comfortable with. There's the need, which says you must use something of a certain version or a certain type. And so you've got that mandated level of need that goes into the infrastructure stack. Then you've got the decision. And the decision for me as an individual compared with the decision as an organization may be different. They may say you need to use this because it meets the enterprise type of requirements, as I mentioned earlier on. Or as an individual, I really don't care as much about that. I care more about doing my job. I might choose something a little bit different. And because it purely enables me to do my job from where I sit much more effectively. And then I've got the platform, which is the architectures, of course. They will change continually, and they will always change. And then the decision, do we go for best of breed, or do we go for a more of a portfolio type of approach? Do we go for one cloud provider and all the tools that they provide, or do we go for a cloud provider and a hybrid mix of tools? There's lots of decisions that have to be made there. You know, the old days of when web design was coming in, where you could have LAMP environments, that is an approach that you could use, but in most cases, you're going to have variations all the way through the stack. And then you've got the incentives. How much does it cost? Cost at the end of the day is going to drive a lot of the decisions. I look at open source, as a colleague of mine once told me, like a free puppy. You know, it's great when you get it first, and then you've got to care and feed for it. It's something that has a cost no matter what. And so whether it is a freemium, open source, or an enterprise technology, it's going to have some sort of cost and support requirement. And then, of course, you've got your limitations. You can't have everything that you would probably desire, or you might not have enough of everything you would desire. So you might be restricted by how much budget. And all these things basically impact what the stack will look like at any point in a DevOps tool chain. And so, and that's the challenge that most people have.
Yeah. You know, it sounds like you're describing every organization that ever existed in terms of how people, you know, how their stacks evolved, how their tools evolved, how their work evolves. So I'm curious to know, you know, how was this allowed to get to this state, and what are organizations going to look to do about it going forward?
Well, so the one thing I want to do is I could spend probably all the time we have just explaining the challenges. You know, I mean, it's not rocket science. A lot of people understand this. They've lived through it a long time. They understand the nuances. It's really how do you get technology today that addresses this? So assuming that all these things are happening and that you can't have a magic wand and fix them, or you can only do it in one or two clients that are ready to do it at a certain maturity layer. It got this way through evolution, and that's the whole point. When you know, back when the environment was basically on-prem storage, compute, and IDE, you could build it up around it, and it wasn't a massive impact on your day. You know, the development infrastructure was much more rigid. It was very project focused. It was long term. So therefore, things could be modified and changed in a much slower way. And then, of course, you add in more and more complexity as the time goes on, and suddenly your infrastructure stack starts to look extremely complex, especially today. Today, more than any other time, when you're moving from things like physical to virtual to container to serverless, I mean, how do you mix those? And you might have all of those environments within an infrastructure, within a corporation. So you've got to be able to say, how does my stack move out? And how do I make the jobs of people who need to interact with it and build it and manage it easier? How do I make it basically, how do I make infrastructure management invisible, go away? How do I get as least amount of interaction with it, give me everything I need to do my job, but don't make it my job? I mean, infrastructure management today can become people's jobs, as whether you use Ruby or whatever scripting technologies are being used, it becomes a big mountain of things that needs to be managed ongoing. So these things, the creation side of the equation is nice, is a nice place to be. The ongoing piece is not so nice. How do I manage it? How do I rip things out once I've finished using them, etc.? So this is how the environment has moved into. Why do people do it today? Well, they do it because no one's really assumed that someone is going to be doing it or a technology is going to be stepping up to do it. So you still do it. People will quite happily provision in the cloud. They'll happily add tools and stuff, but it's changing. And this is where the scale comes in. How do you scale something that is getting more sophisticated, more complex, takes more time, and changes constantly? These are all the dynamics of what you have to do. So again, this is a very much a basic outline. I mean, I'm sure that people do this. In a team, you don't see the scale issues that much. You might see scale in a different way. You see it on the complexity of the applications. You see it on the complexity of the architecture you're putting together in regards to the hierarchy of infrastructure. It only gets more complex as DevOps, which is maturing at a rate that's just beyond belief at the moment. I mean, everybody's adopting it, and it's becoming an extremely accepted practice that people understand what it is, understand what the objectives are, and how to work it. What hasn't been addressed is how do you manage DevOps at scale? How do you manage to get all these pieces that had the freedom to do whatever they wanted in support of the company initiative at the product level to be managed at the enterprise level? Because obviously the infrastructure instances are going to be more, the components are going to be more changes, there's going to be more changes and more frequent changes. So not only are they going to be more, but they're going to happen more frequently. And then you've got all the infrastructure management, you've got the teams, and not everybody has a DevOps organization that looks the same. So some are very small pizza teams, small collaborative teams of groups of people, others may be larger, and they call it a DevOps because that's the practice they're adopting. It's not necessarily the organizational design that they're adopting. So the practice is accepted, the teams will be different, the methods that are aligned to it. You may have a lean practice, you may be adopting SAFe, you may be adopting something underneath the hood that makes it even more sophisticated. And then you've got all the tools. There's no shortage of tools today. There never will be, by the way. So, you know, the tools should make things go away. They shouldn't add something to your day. You know, this is the software industry. As a software industry, we always think that adding something makes things simpler. And that's the problem. When you add much more layers, layers of abstraction is well accepted at the enterprise, not so much at the development doer level. Abstraction sometimes masks capabilities and the ability to really get into the weeds on the technologies and actually do the work. Abstraction provides visibility, so you've got to be very careful on making sure that both those attributes are met. And then there's also the environments, and there's going to be, today everybody believes, you know, Amazon on its path to world domination is bringing in, Amazon's in there, Microsoft, Azure DevOps, all these other technologies are coming in, Google, no matter what you use, IBM. These types of technologies, it will be a time in the history of IT, there will be an evolution where these technologies that are so critical today and that no one can see the end of the light on, they're definitely going to be growing. There might be something that happens in the next decade that changes the makeup completely. And it's usually due to the fact that as the larger you get, the more agile other innovation comes in, it changes the game slightly, modifies how things are done. So you've got to be looking for that. So even today, there are very big, dominant organizations that are responsible for infrastructure and can provide you with that capability. In the future, that may not be the case because innovation doesn't play to a specific company or a approach. It plays to the needs of the business applications. So the one thing about working in companies that I have and with Quali, what we're looking at it is when we design our technology, we've got to go in there with a whole sense of reality. There's got to be something that says our technology has got to be able to do these things based upon things that are happening, you know, managing it, not trying to change it. So the applications will determine the infrastructure. That's the first thing. The reality is applications determine infrastructure. Infrastructure should not inhibit how an application works. And so the application will always be the overriding stream, which means that the DevOps environment comes into its own because it's application focused initiatives and the infrastructure to support the application at any point in time. The teams will be able to use whatever they want. You can't inhibit people. You can limit some of the options, but let's assume that innovation is going to drive new technologies. So teams will start to use things and move them into the infrastructure stack. Change is going to be constant. So I've mentioned that many times. Change is the killer of all things. There's two things that will break great products going forward. Change is one of them, the speed of change and the rate of change, and infrastructure organizations. Bad organization will eat strategy for breakfast. So you've really got to have the ability to have organizations, no matter how fragmented or how mature or immature, they've got to have a path of progression. So as you put the skills in place, you shouldn't assume everybody has a high level of skill with which to interact with the infrastructure. And you shouldn't accept the fact that the people that do have the skills will be satisfied with an abstraction layer that doesn't give them that capability. So you've got to have a technology that both gives you the capabilities at the grassroots level, but also enables people with less skills or less need to get involved with it to be able to interact with the infrastructure technology as it exists today. So the complexity will continue to increase on that one, and that's why the skills and the guardrails around technology and how it works should be done. And then there's the life cycle. Life cycle of infrastructure is an interesting one because people look at the infrastructure life cycle differently. Some people will look at the infrastructure life cycle as the piece of the infrastructure that is around when they do what they need to do. Outside of that, it's got its own life. So for example, where planning comes in, they plan something, they say it needs to look like this. This is what the application needs to do. That drives the infrastructure requirements. That then drives the build and the development teams. That then should drive how the testing team or the person that does the development and the testing combined works together. So whether it's a single person or whether it's multiple teams, you still have to have an infrastructure that delivers capabilities around development, capabilities around testing. And then that will actually mean it goes all the way through, and there might be a point where that piece of that code or the piece of infrastructure that's being built will go away. It shouldn't be assumed that it's going to magically disappear, but it's going to go away. So you've got to be able to extract it from the infrastructure and say, I no longer need it, I want to archive it, I want to delete it, and it's got to remove the whole top to bottom infrastructure stack. No matter what's been changed, what's been modified, it's got to be captured and removed. And that's where a lot of the immaturity exists, is where infrastructure is created and then bits of it stay around, or the whole thing stays around for longer than it needs to be. So the infrastructure lifecycle can be all the way from planning through to the production side. If you're really heavy into service and modular architectures in your application, it's more likely that infrastructure is going to remain more intact as it goes through the development cycle. Or if it's much more traditional in fashion, the application will look differently in the infrastructure side and on the application side as it does in the actual production side. So it ties in that the infrastructure will change. There'll be a point in time where it goes away, or there'll be a point in time where it modifies itself to meet other needs. And you've got to be able to understand exactly what it is it's doing, what state it's actually providing you, and if it does have an end of life and it isn't used anymore, with a click of a button or a time frame being met, it should go away. And that's what we're really talking about, the reality of the life cycle. So the other two examples are just examples of what we're doing to actually adhere to that and what shouldn't be done to make reality, not trying to change it.
Right. So yeah, that's a really good vision of where things should be going from the reality. But I'm just curious to know, do you see this trend continuing? Are more organizations adopting it? And if so, what actually are they doing to move in this direction?
Okay, so what I'm going to show is the details. There's a reason that there's a whole bunch of reasons why this is a build. So I always resist, if I can, PowerPoint that looks like, for those of you who are old enough to remember microfiche, you know, we have to look at it through a lens and see how it is, but this is going to look a little bit microfichy. So I'm going to explain it in a very, as logical as I can. First of all, the DevOps lifecycle in the middle there. I'm fully understanding that that's probably the worst representation of DevOps. I was involved in some of the development around this graphic. It really should be assumed that every single one of these things, assessing, the planning, the building, the testing, is ongoing, it's looping, it's all the time, integrated, it's always working. This purely shows the capabilities that you apply to that process. So when you look at this, different people get involved, and personas at the end of the day will drive what you need from your DevOps environment. So developers need to build, testers need to do the quality. So you can see how that works. Very blindly obvious, but that's how, in most people's eyes, a DevOps process should exactly look like. Then you plot on that where the infrastructure plays. What's the infrastructure doing when you're doing all this magic through the lazy 8? Well, the infrastructure being planned may not be, may purely be, I need the application to exhibit these requirements. As you move from into your stories, from your epics, so you've got your epic that says, I will be developing this. You've got your stories underneath that says, these are the things that I will be doing in support of that epic. The infrastructure may be required to be doing different things in support of each story that goes out. And then the infrastructure is created to provide the build, it's tested, it's released, and you can use the infrastructure may be moving through. So there are two things I'm going to show here. One is this is what normally happens. This is an example, but this is what can happen in a DevOps cycle of infrastructure. And I'm assuming, by the way, that everybody in each of these steps is looking at it from a life cycle perspective. So if you want to do demo and prototyping and testing, you want to be able to plan it, build it, and use it and retire it. You want to see if it works. But it's the life cycle. That's what the life cycle of infrastructure is. You take those learnings, you give it to the development organization, and they build it. Now, as you can see throughout this process, it looks like it's new. 1, 2, 3, 4. As it goes through, each one is created, it's planned and built and used. Ideally, the state is that the infrastructure should follow the DevOps pipeline. It should go like fluid through that lifetime. And as it changes and the stack modifies itself to meet the specific capabilities of each of the people and what's being done, it doesn't mean you lose sight on it. It doesn't get created again. So you can create it again, and it typically happens a lot. But what could happen with the right technology is that you build it, once you built it, you then test it using some of the build environment that was inherited. That's why it happened. And think about this scenario. If you can test something and you've tested it based upon the build, and then you've tested it within the ring fence of the infrastructure that you've got in front of you, and you move that policy of what the testing did, so it met 100% of this, it provided these capabilities. As it goes into production, it would be a cool idea to actually keep policy that was based in testing intact in the production side of the equation. Because if that happens, now you're looking for variances, because obviously as it goes from 3 to 4 in this graphic, it goes from clean to the Wild West, because nothing owns anything in production. It's all shared, databases are shared, network is shared, everything's virtual, nothing is unique, nothing is really owned specifically. However, it'd be much easier to understand what the impact of the change is going to be within what's being developed if you actually have an infrastructure that says, this is what it did within this infrastructure. When it went into 4, this is what it did here, and now you're looking for variances. It only met 93% of that. It did this. It gives the ability for other technologies to feed from the infrastructure stack and say, I now know what the map looks like. So for those of you who know ITIL, they look at configuration management databases and various things. That's a lagging indicator, because very rarely is it totally up to date. If you think of this mechanism of DevOps as it goes through into the future, you're actually using a known state with which to measure production. You're not using a discovered state, it's a known state. It's what planning used, development used, it's what the plan has built. And so as you modify the configs and you modify and adjust it, which will happen no matter what, because nothing owns it So you modify configurations to make sure that multiple applications can use it. So as you modify things, the change should be captured within the infrastructure management component and say, this is what's been changed. So it's suddenly accountable. But that's the two methods. So this is a real design on, these are the two approaches. One, you can build it and have a life cycle within each area, or you could actually use the architecture that you built within the infrastructure stack all the way through by removing some of the complexities and actually using it as a life cycle tool, not purely as an enablement tool for other parts of the DevOps environment. So this is what I meant about, so who cares? So I'm talking to you now and you're probably going, okay, what's in this for me? Why do I care about all the things that you said in regards to certain aspects? And I think when I talk to the development or the dev teams and the DevOps teams, and in some cases the dev teams, they all have various requirements and needs from the infrastructure. Having a technology that only meets the higher end enterprises is good for the enterprise. However, the development organization typically has its opinion on what it needs. Why does it help me do my job? So the technology that needs to be done for the infrastructure management has got to provide the features and the functions and the integrations and the flexibilities that meets the requirements of the DevOps or the operations-centric teams and has the stack viewed from that perspective. But that information should then be purposed so the business understands what that means as well. So as each team is using the infrastructure technology to build and move the infrastructure along the DevOps pipeline, what happens is that the business can now look at multiple products, multiple teams, multiple instances, and then understand what it looks like at the bigger picture. So what's good for development sometimes isn't good for the enterprise because they don't know how to translate the information. And what's good for the enterprise is not always good for development because it doesn't know how to interpret it correctly or add value at that level. What is really required is technology that can provide both these views without inhibiting one or the other practice. So when we look at this one, and you'll have to forgive me for this, I've been an analyst part of my life, so if I ever get the opportunity to present something that looks like a maturity model, I'll always leap on it. But this isn't meant to be that way. This is really meant to be a double-edged type of thing. If people want to know where they want to go, they need to know where they are. I know that's a stupid thing to say, but it's basically that says, if I understand where things are going and where I need to get to, and I understand where I am now, I'll be able to work out what I need to do and improve to actually meet the next state. So I don't really have to read all the information on this PowerPoint, but basically what it's saying is that there are certain things that need to be done that say, if you look at like this at a culture perspective, if you have people that do this and you've got a process that does this, these are the likely things that you can increase. And within Quality, we built various models that enable people to move from the people perspective and the process. You've got to be able to support these things. At the end of the day, the technology can't bludgeon process and people and culture. It's got to be aligned. You've got to be able to say, are you ready for adopting this? Have you got the people that have got the skills that enable you to adopt it? And you should have technology that moves people, helps move people from the left to the right, whether it's one technology or a whole portfolio of technologies. It needs to be able to show progress because that's the ROI. The ROI is not just dealing with what happens today, but how does it help my business move forward in the future? And how does it make me a better person doing my job? Because at the end of the day, people will look at technology and work with technology when they're rewarded against it. So having a reward system that says we're measuring you on efficiencies, we're measuring you on throughput, quality of code, that's one set of measurements. The business may be saying we're going to measure the whole end-to-end on business value. You'll hear a lot of things about business value streams or value streams generally, but a value stream should say, I'm going to enable you to understand what you did contributes to the bottom line. And this is a way to actually say, what I'm doing makes my job better at the rudimentary, at all levels. I can be a better manager, I can be a better coder, I can be a better tester, I can be a better executive. It really depends on what level you are, but it gives a point of reference that says, this is what it is. It also says, if you adopt this to the product teams, because this is not an organizational view by any perspective. This is really a team view. How does the team work and how do the product teams work that enables them to move? So you should be, in theory, be able to get hold of this and say, this is where my teams are in their level of maturity. And this is why they're either at this level or at this level. This is what we're going to have to learn from this group to move this group. But that can only be really done when it has a framework with which to map it across things that will impede each other. As I say, people, process and people, that needs to be really in place to help the technology be subsumed. You can't have technology that is misaligned with the other areas. So as I say, this is where we're really looking at it, and this is how we're helping companies move really from the left to the right by saying, this is where you are, this is what our technology can do for you at this moment in time, this is the value it provides, and by the way, this is the mechanisms from the infrastructure management perspective, it can help you move to the next level. So this is the one thing that I think is important, is that infrastructure lifecycle is actually a game of two halves. What I mean by that is this: day one is known by everybody. Because they say, how do you compete with, you know, configuration tool of choice, you know, or the scripting guys, or the cloud providers, or this. When you look at the role that needs to be done and the job that needs to be done, most people focus on day one. How do you plan it? How do you host it? How do you provide the capacity? How do you choose all the options? How do you build it and use it? I mean, those are the things. I will make it and they will come. So it's all the things about day one. I will get these things done. Day two, that's a bit ugly, because day two is when that puppy that I mentioned earlier turns into a dog. You got to feed it, care for it, take it to the vet, do all the other things. You got scale. So first of all, it's going to get bigger. It's going to be different. You need to govern it, make sure that the changes are managed and everything is adhering to security policy, etc. You've got to be able to manage it. You've got to interface with it and understand what's going on. You should be able to add to it. You should be modifying it and get it going, and modify it from, you know, what was developed from day one. So adding and changing should be inherent. You might have to pay for it, which means that as you add, manage, change, do these things, the cost increases. So if you're using a cloud provider, the costs are going to go up. And you may not be caring about that, or you may care about it, but you should at least understand that paying for something comes as part of day one's initiation. So eventually someone's going to have to pay for it. And then eventually you may have to retire it. I want to move it out of that infrastructure. And retirement can be a real, when you start removing things, it can become extremely difficult, because you got to remember where things were, who's done all the changes, who's done the modifications. So that is why it's a game of two halves. So when we build lifecycle infrastructure automation into this, it enables both these parts to be done. And you should get day one and get day two for free. The technology should do as much of day two as possible, because that's where the labor and the grief end up. That's where that measure of taking over my day kicks in. So it's not in the planning and the building. Most people can do that today, drag and dropping the build and building, getting Ruby to do your configurations, but really is around how do I deal with it ongoing. And if you can make that invisible and go away on day two as much as possible, that means you can still focus on day one. And that's the whole point of moving from day one to day two. It's got to be treated as the same thing. It can't be treated separately. That's how we differentiate from a lot of our competitors, because day one is where they live. And the one thing that most people want is, I don't want to wait for this stuff. I want it now. And I was determined not to burst into song there from a commercial, but basically you want it now and you don't want to have to wait for it. You want to be able to initiate it. And that means that whatever skill level you are, you want to be able to build it and create it and get it up and running as fast as possible. So if you look at this as sort of like a way to actually build a blueprint defines what you have. It says, this is what I need. This is what I'm building it around. And the blueprint gets modified as it goes through the processes, etc., as it goes through the infrastructure and the DevOps processes. And think of it like an infrastructure Git. You know, it's the way that you should be able to say, I know how it changes from planning all the way through to the production environment, but I can get it up and running. And by the way, I can snap it back down. I can bring it up in the morning and bring it back down in the afternoon. I can optimize my costs, or I can optimize my usage, and it goes away. And those diagrams on the right are just examples of how, you know, we as a company are putting something together where the pieces that come together that make up the blueprint is in one place, and then you can control that blueprint and say, oh, this is for infrastructure X, or this is for the application or the network, or whatever you want to cut it up into pieces on to address that complexity thing that I mentioned very early on. And then you can move it into this sort of environment where you can just name it something and you can pull it and you can share it. So it's all about sharing, leveraging, reuse. Even if you remove the infrastructure, so the blueprint stays there, you can bring it back up again immediately. So you can bring them up and shut them down as often as you want, knowing that you're going to get the same case. You don't have to leave it out there and worry about modifying it and breaking it. So that's the point about having it very quick, but also managed. So the speed of execution is not a detriment to ongoing management. So in summary, and I'll take a breath, I promise. So what does this look like? So what I'd like you to take away is this, is that the full stack infrastructure delivered, it should be managed and distributed no matter how distributed it is. You should be able to get the full stack no matter where it is and who uses it. And it should be managed in a way that enables you to have a coherent understanding about whether it's building or testing or releasing. You know what it looks like and you've got a good view. And if you only care about your testing, you may have a whole set of testing technologies and infrastructures. Same for building, coding, you can do whatever you want there. So you're looking at a set of tiers and hierarchies that says, I've got a bunch of builds, I've got a bunch of tests, I've got a bunch of releases, and these things can be the same infrastructure with modifications, or it can be different. And then you want to be able to build and forget it. As I mentioned before, day one, create and use it. Day two, govern, retire. I want that managed. I don't want to deal with that. I want to be reminded when it should go away. I want to be reminded how many uses it has. I want it to be automatically managed on change. I want that to be managed in that way. And I want to be able to innovate. I don't want any inhibitor, don't tell me what I can use or not use. Development has never really adhered to big governance type of practices. If development teams are really issued on innovation, differentiation, and business value, then the ability to allow development teams to use what they need to do their jobs should be tantamount as part of that. And it shouldn't be expected that they're going to be restricted in some ways. So the innovation is going to continue to exist and freedom of choice will continue to exist, but it needs to be managed. And that's what I'm saying about the management of the infrastructure. It needs to be brought into line. And also the protected investment. If you've got a lot of IP sitting out there where you've been building scripts and all sort of configurations, I mentioned earlier on that you shouldn't, adding something and not removing something, augmenting it. The technologies that we provide at Quali, we can embrace a lot of the technology that already exists in the space today, whether it's a cloud provider or whether it's something that creates infrastructure from a more scripted view or configuration view. You can definitely protect those things and use them and bring them in. However, the objective is to make things simpler from end to end. And to make things simpler, the objective should be really make things simple. And that means removing the complexity where it can be removed, irrespective of whether the technology is there or not. Make sure that you can do everything you want, use the minimum amount of capabilities you need, but give you the full stack infrastructure management. So protecting the skills is really important as well, obviously, and the infrastructure blueprints, make sure that they're cost attract and that the infrastructure is managed well and efficiently. And then lastly, look at it like a life cycle. It is a life cycle, whether it's 10 minutes or whether it's 10 years. It's going to have a life cycle. Things are going to change, modify, add, remove. It's nice to have a single point of truth. A source of truth is what people are looking for, and one common control point that they can actually look at and say, I know what's going on because I've got that in there. And by the way, when I use it, it's subliminal. So it's not in my face every day, but it will tell me what's going on and give me the information I need. So with that, I'd take a breath. I'd like to thank you for your time, and we can, Dave, open it up for some questions.
Yeah, great, Dave. I'm sorry, I had a couple of questions earlier, but one of the joys of working from home is my landscaper came by with his gas-powered leaf blower, so I had to mute myself so that you could be heard. But he seems to have moved away from the house now, so we can get on with the questions. I just want to remind everyone that we have about 10 minutes left for questions. If you have one, once again, just type it into the questions tab in the control panel. And as I said earlier, we'll get to as many as time allows. But before we do that, when you were talking before about infrastructure end of life, and I know you kind of went into a bit of a description, what do you mean by end of life of infrastructure? I think maybe people could use some clarity on that.
Okay, so the infrastructure end of life is, I look at it in like 3 buckets. I'm going to see if I can get the buckets in order. So when the infrastructure is created and definitive around the timeline, so for example, an infrastructure time could be, I'm going to use something for a week. I want to prototype something, demo something, put it in a lab. It needs to have a life cycle, and the life cycle is really between the creation and the retirement based upon a timeline. And you can put that in, you should be able to put that in place that says upon that timeline finishing, you can it will automatically remove or ask you to be removed. It will remind you. The second one is, the number of teams that use the infrastructure. the last team that issues the remove request. So for example, if you're using it as my example, my PowerPoint here shows the life cycle can be the whole DevOps life cycle. So it can be when I'm using it and how I'm using it, not necessarily a timeline. It's based upon what I need to do as opposed to a time that I need to get it done by. So it can be a continuous improvement infrastructure that says I'm going to modify my infrastructure and modify it as it goes on, doing continuous improvements to it, modifying it, and the timeline. So the real life cycle is that complete life cycle. It's going round. It's basically being created, modified, updated, and then modified, updated, modified, updated, and that's the life cycle. But it continues to change that, and eventually it can either morph or it could actually retire it, and it'd be the last person that touched it retires it, and it brings it all out. As I say, it should be extracted almost seamlessly. And then last one is really an augmented enhancements. So for example, how do I change stuff? So the change is about a life cycle should be something that's never going to go away. It's always going to be there. So more on the operational side, not less of a life cycle, but more of a constant change. I'm going to have a piece of infrastructure here. I'm going to use it. I don't even know when it's going to be finished. It's a business requirement for that being used, but I want to make sure that the life cycle of it, while it's alive, that the changes and the infrastructure modifications and the enhancements made to it are all captured and made efficiently, so I can interact with it without disrupting the business. So it's much more of less of a loop, more of a traditional view from end to end. So timeline, loop processes, and a life cycle based upon a never-ending time.
Excellent, great, thank you. So we do have a question from one of our attendees who was wanted to know if you could explain what a blueprint contains and does that differ from a configuration plate?
Well, the blueprints are like an infrastructure DNA. So the entire stack is defined and managed using the blueprints. So you have a blueprint model that goes from end to end. So they're used to create, and you can duplicate them. They're like an entity on their own. So as I said before, it's like if you think about it like an infrastructure Git. You've got all the version controls, the information about the infrastructure parts, the connectivity between these parts. I think the main difference is that the scope of this is much more broad. It manages all the tools and the pieces that you apply to the infrastructure in that full stack way. A lot of the configuration tools that are used are much more around the lower level infrastructure pieces, the cloud pieces, some of the network may be specific, but this is much more an end-to-end stack. A blueprint is itself it has its own life, it has its own version. It is a representative of a state in time or a state of infrastructure. A configuration is typically the plumbing with which technology will work on an infrastructure, and therefore modifying it would still take some work, and also the scope of it would be required to be fairly high, because the skills level would need to be pretty high for you to actually make, like I say, entrepreneurial additions to it. So it's slightly different. One's more of a module, the other one's much more of a sequential set of scripting.
Very good, thank you. Another question came in. Well, one thing that I will mention, we have a couple of questions from people wondering if the slides are going to be available. So I would say yes, we're recording this, and it will be available on sdtimes.com, certainly either later today or certainly by tomorrow morning. So hopefully that answers all those questions. Okay, somebody wanted to know, based on, I guess, your last answer, and is just curious to know, doesn't an infrastructure platform just add another layer of complexity?
Yeah, it's true that unifying the different infrastructure components and tools does up-level the visibility, but the objective is, not to abstract away the dependencies and complexity, and not mask or abstract how the tools deliver the value to the DevOps team. So each tool in the infrastructure build that plays a part in the tool chain is still fully functional. So you're still interacting with it, but absolutely it can be used as another layer of abstraction, but it shouldn't add more complexity. The whole point of tools that do abstract, or at least bring things together and enable you to get that information, is one, the way that you interact with the underlying technology should be up to the person that uses it. The practitioner should be able to say, I need to get down to that level of information. And then the second thing is, it should provide the capabilities of integration between these things, showing you how these things work. So again, you're not looking at basically the old version of the MOMS that used to exist, the manager of managers, where everything still sits with its own administration. You still got to do all the work and it comes up and it gives you that more. What you want to do is remove a lot of the capabilities from the infrastructure that says, I don't need all these disparate pieces. I can integrate with them if necessary, but I should be able to augment and enhance them as opposed to just create another layer of management. So the whole point of infrastructure management should be to make it invisible, go away, take the information you need and abstract it, and yet still provide capabilities required by the practitioner to interact with it. So it's a delicate balance, but no, so the answer really is it doesn't add more complexity. It does smooth out the way of actually integrating with the infrastructure, but it shouldn't remove people's ability to interact with it as they wish.
Mm-hmm. Great. All right, we have time for one last question. It's an interesting one about the cloud providers and the fact that they often provide ways to build and manage infrastructure, such as Azure DevOps. So how does this align with what you've just been describing?
Well, while a cloud provider provides a menu of supported options, it assumes a level of standardization on specific parts of the stack. So you obviously, if you go for one cloud provider, a lot of them are actually trying to move on each other's territory today because that's what they want to do. They want to become much more, for want of another term, heterogeneous. So they want to be able to provide that capability. But a lot of the broad mix of tools comes from outside of the menu or comes from different parts of it. So what I'm saying is you are limited in some ways to what the cloud provider will want to give you, because at the end of the day, the optimization and the ability to remove things up and down quite happily to optimize spend isn't necessarily to their, that's not what they would not like that very much, even though they would say, yeah, of course we want you to do that. So open source, there's a lot of open source sitting out there. There's a lot of other technologies that you'd want to bring in. You might have a homegrown technology that you want to bring in. So you've got to bring that into the cloud. So as long as you've got one standard infrastructure, one standard cloud, one set of tools you're happy with, surely that might be a way of doing it. But to be honest with you, most organizations have a long tail, different architectures, different applications, different areas of focus, and the complexity is something that you could host there, but it's not something that they would normally provide you with in the way that I've described it today.
Mm-hmm. That's great. Well, Dave, I certainly want to thank you for a great presentation today. I would also like to thank Quali for sponsoring this presentation. So thanks for that. And I also would like to thank all of our attendees for joining us this afternoon for a great conversation about managing your infrastructure. So until next time, I'm Dave Rubenstein, Editor-in-Chief of SD Times. So long for now.